Hello to our Griffin Year 5 families, Mr. Grewcock here. Today I just wanted to go over a few of the things that our Year 5 Griffins will be looking at maths over the next half term. We're going to be primarily focusing on geometry, on properties of shapes and position and direction. So we're just going to go over a few examples of summarising some of the bits and bobs we'll be looking at this term. So first of all, we've got three clock faces. If we imagine the hour hand is stuck at 12. Here, it's asking us to show an acute angle using our minute hand, a right angle using our minute hand, and an obtuse angle using our minute hand. So an acute angle is an angle that is smaller, that is less than 90 degrees. Our Year 5 Griffins should already know that a right angle is a 90-degree angle and our obtuse angle is larger than 90 degrees. So, if we have a look here, any time between 12:46 and 12:14 would create an angle that is less than 90 degrees, as we can see here. On our second example, our minute hand must be either on the 3, on the 12:15, or on the 9 at 11:45 in order to get that 90-degree angle, as we can see here. And finally, an obtuse angle, our angle that is greater than 90 degrees. That would be any time from 12:16 and 12:29 and 12:31 and 12:44. The reason it wouldn't be at 12:30 would because that would be an angle of 180 degrees. So we wouldn't label it as an obtuse angle in this example. Now here, still thinking about our right angles, our obtuse angles, and our acute angles. Here, I have got three images. Within the image, you will see a coloured angle. We have been asked to label each image with the name of that angle. So let's start with a 90-degree angle. If we have a look, can we see an example of 90 degrees? Well, here, now I can see that angle is far too small to be a 90 degrees, so it's not going to be C. If we have a look at B, well, I can see that is much greater than 90 degrees. So let's have a look here. Aha. Yes. I can see that we have got a right angle here. We have a 90-degree angle that's not been highlighted here, and a 270-degree angle that has been highlighted here. So A is our right angle. Now, an acute angle. I can't remember. Was acute? Acute is a smaller than 90-degree angle. Nice way of remembering it is acute angle, okay? It's our acute angle. So which is our cute small angle? Well, if we go back to C, we said earlier this is less than 90 degrees. It is our cute angle, our acute angle. Leaving B, as that must be our obtuse angle. Now, finally, here we're going to be briefly touching upon polygons. Now, we've got a collection of statements down here that we know about polygons. We need to label them as either true or false. So, what is a polygon? Well, a polygon is a two-dimensional shape. Doesn't matter how many sides it's got, as long as it is a closed shape. And what this means, no gaps. They are made up of straight lines, not curved lines. They are always straight lines. So when we'll be working on polygons, we will be using a ruler when we are drawing. And so no curved sides. If we have a look at our final slides here, we're going to be looking at the difference between a regular polygon and an irregular polygon. If we have a look here, a regular polygon, we have a four-sided polygon we know as a square. A three-sided polygon is a triangle. A six-sided polygon is a hexagon. These polygons here are what is known as our irregular polygons. Now, finally, that's all we're going to be looking at with regards to shapes. We're also going to be looking at position and direction this half term. So I'm going to really quickly show you the sorts of things we'll be looking at. So here, we've got 4 statements that we need to do. We need to label our x-axis, we need to label our y-axis. We need to discover what the coordinates are for A, B, C, D and E. And the other question it asks at the end is, does it matter which way you write the numbers? Now, first things first, we must label our x-axis. Our x-axis is always our bottom horizontal axis, and our y-axis is always our vertical axis. When labelling, all we need to simply do, write an x, write a y. Our axes have been labelled. Now, when searching for coordinates, we always look at the x-axis first, then the y-axis. So, if I was finding the coordinates for A, I would start at 0 and I would go along to 3. I can see that lines up with A. I then will start looking at my y-axis. So going up, 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 I can see that A is 5 on the y-axis. Now, it does matter the way we write these. We write the x first, followed by the y. So A would be at 3, 5. The reason we write it in this order is if I wrote 5, 3, that would take me to here, which is actually quite a bit off. I'm going to stop there for now, but this is just a quick, brief look at what we were looking at next half term. Thanks so much, everyone.